So, good morning. Very warm good morning. All the best. Give you a nice shot this time. Okay? All right. Hope you have prepared well this time. Thank you.
Sir. Okay.
Hold it.
Good morning, respected teacher and my dear friends. Today, I'm Sneha. Today, along with my teammates Rinam, Pragya, and Dolly, we are here to present relative motion. So, what is relative motion? Relative motion means the motion of an object with respect to another object. It is important that motion is always relative to something else. For example, if you are sitting in a moving car, your motion is related to the car. So, here is Dolly to explain the rest.
Motion depends on the observer. The same object can have different speed and direction depending on who measures it. What changes? Speed you measure, distance you see. What does not change? The actual event, the distance, the motion is the object motion is the same. Only only the viewpoint changes. A mini example: a person sitting in a bus is at rest to the bus but moving to someone else. Reference frame and relative velocity. The viewpoint you measure from ground to ground, versus water, etc. Relative velocity, how fast A moves compared to B. This will explain by Reenam.
So, in this case, there will be two cars and one in motion. And car B is at rest, and car A is moving forward. To a person sitting on car B, car A is seen in motion, and to a person standing on the road, car A is also in motion. So in both the cases, car A is seen in motion. So this shows that the motion depends on the observer.
Bus move forward relative to ground. Students walk forward inside the bus relative to bus. What observer sees? Observer on the bus, student move at walking speed. Observer on the ground, students move faster. Bus plus walking speed. Now Pragya will explain the rest of the examples.
So here we have two trains passing each other. There are two cases here. So when uh, the, the train A and train B moves together, like they move in the same direction, um, it appears to be that train A is slightly more faster than train B from the observer which is standing on the station. But the person on the train B, it appears that train A is like going slowly, like in the same speed as the train B, because the train B cancels the part of the distance that train A produces. And now in opposite direction, sorry, when train A and train B comes in opposite direction, it appears that train A and train B both sees that they are coming faster, and when they, like, travel faster, the speed adds up and the relative motion changes to faster. So here we can say the relative speed equal to speed of train A plus speed of train B. And now I will, not me, but Reenam will explain why rain looks slanted when we move.
So this is a very common real life example of relative motion. Rain falls vertically, but to a person standing still, rain is seen straight. But when we walk or run, our motion adds a horizontal component. So rain appears to come from the front. Rain appears to we walk or run, our motion adds a horizontal component. So rain appears to come from the front, so the rain looks slanted. The key point is rain is falling vertically, but because we are moving, the velocity of rain relative to us changes.
The last part, which is boat crossing a river with current. There are two situations. Okay, so boat is relative to water, but the river current is also relative to the ground. So here two motions are acting together. So that's why, as you know, both cannot, like, boat cannot change the river flow. So that's why the boat are connected together, and they act as a, and the motion act together. What uh, what a person see from the shore. So they see that boat is moving, but it is also slightly pushed by, getting pushed by the river currents. So it appears that the boat is moving in a diagonal or slanting path. Now problems. No, sorry. So our first aim would be to like travel from the our position to the opposite position. So we have uh, the the boat engine is like, put it in upstream, but the river flows, the river current pushes it downstream. So uh, so the boat, as the upper, like the river, sorry, the boat, the stream cancels the downstream flow, so that it takes, so that it goes directly on our landing position, but it takes more time. And now in problem 2, the boat is like directly going in the straight position. So there is no the upward motion, but there is the downstream motion that directly pushes it to the, like, not in the same landing position, but it difference, but it takes less time. Thank you.
This time they have improved a lot, but little nervous you were. I find perfection from her. Ekdam perfectly you spoke. Very good. Any question regarding this topic? Relative motion. What is motion? Okay, one question from here.
Okay, so why does motion need a reference point?
Whether an object is moving or at rest, it depends on the observer. So the observer is the reference point. That's why we need a motion. That's why we need a reference point.
Very good. Very good. Any question?
Moving of an object.
Yeah, an object changes its position with time, right? Okay. So now, suppose he is sitting. Our Nihal is sitting. So according to you, is he in motion or is in rest? Is in rest. Okay. Now suppose if he's been seen by someone who is in moon or in space, how it will appear for him? Huh? Yeah, space. Someone, suppose an astronaut is zooming to our class and looking to him. For a astronaut, how the object will appear in the earth?
It will appear moving
Why?
because the person will move. So according to his,
Sitting.
no, but when someone zoom na, then the zoom that space it is, he or she will be moving na.
Good. This time, like now, suppose you are sitting in a train and your friend is also sitting in the same train. For you, they are sitting only, rest. But person who is sitting from the station, who is looking you are from the station, for him, you will be appearing as a moving reference point. Thank you, thank you. Very good. Well done. Okay.